it is k. K is a constant which is 1 over 4 pi epsilon. So since all the charges are the same, so it's just q times q. So I will just straight away write q square r so q squared divided by the magnitude of r raised to the power of 3 times multiply with the vector r. So we have all the vector r already, and I think the magnitude of r can be, is easily calculated from here. So first we need to find what is the k value, which is 1 over 4 pi epsilon naught. So I'm going to use here the epsilon naught as 1 over 36 pi. You can, this is just, it's a good enough approximation. You can find it out in your calculator. There's a certain constant number in your calculator. I think constant 32, something like that. I'm not sure. I can't remember. You can find it out. But I'm going to use this value. Is a good enough approximation. So if I choose this as my epsilon naught, the permittivity of free space, then the value of k is 9 times 10 to the power of 9. Okay. Excuse me. Okay, first we're going to find what is the force B to A. Times Q which is 50 times 10 to the power of negative 9 square. And then the magnitude of R cubed. So the magnitude of R is 2. So 2 to the power 3. Multiply with vector RBA. So it is 2x cap. Then we have F force to C to A. And the magnitude is square root of 2. Square root of 2 cubed. And it is x cap minus y cap, right? X cap minus y cap. So what is the value of this? So so this is 2.25 times 10 to the power negative 5 over 4 x cap. So this is 2.25 times 10 to the power of negative 5 over 2 square root 2 x cap minus y cap. And for RDA is similar to FCA. It's just a sign change. Yeah. Yeah. So I will write directly FDA as 2.25 times 10 to the power negative 5 over 2 square root 2 x cap plus y cap. Okay. So therefore the net force at point A. So therefore F net at point A is 2.25 times 10 to the negative 5 . So here we can see if we add FCA and FDA, the Y component is going to be cancel off each other. So leaving only the X component. So if we look at FCA and FDA, so the X component of FCA and FDA added, so it's going to be 2.25 times 10 to the power negative 5 over square root 2 X cap. Okay. So what is the value now? So the final value is 2.1534 times 10 power negative 5 Newton. Okay. Or 21.534 micronewton. So that's for question 1. So I think for question 1 part A, the calculation is straightforward. You just need to be careful. Yeah, you just have to do it step by steps. I think I saw briefly some of your answer scripts. Some of you even, I don't think you managed to get the correct answer. Yeah. So you just I think the reason is you didn't do it in a systematic way. So when your calculation is not in place, I mean all this calculation I mean you should know, right? This is just application of Coulomb's law. So the main reason is just that perhaps how you organize your calculation is not there. Therefore, you couldn't get the correct answer. But if you show it step by step, even if you get the wrong answer, you get almost, I would say, 80% of the marks. Yeah. I mean, the final answer, if let's say you didn't manage to get the final answer, but you show me the step by step and how you proceed with this, how you proceed with the calculation, and it makes sense, I will just I will just give you 80% of the marks most of the time. So only 2 marks. Let's say this is 10 marks. If let's say this is 10 marks, I will just minus off 2 marks from your final wrong answer. Okay, move on to part B. Okay. 2-point charges of Q and 2-point charges each equals to charge capital Q and mass mq are located at a distance d apart. An electron of charge E and mass m of E is held in a position on the center line between them and at a distance x from the line connecting the 2-point charges as shown. So assume that the mass m of Q is greater than m of E. So basically this condition here basically tells us that um, if this way, if this is greater, okay, so the mass is great. The mass of the positive charge is greater than the mass of electrons, mass of negative charge. So basically, it tells us that okay, the motion will more likely to involve uh, the electrons rather than the mass, the charge capital, the charge Q, the positive charge. So it is more likely that E, the electrons will move towards where the positive charge located, rather than the Q move towards E. So basically, what are they telling us that okay, these two charge are most likely to stay stationary. They more likely to stay stationary, and the E will move to the direction of Q. So assume and in order and for this problem, there's no gravitational force involved. So assuming that initially E is held at a distance x, yeah, the electrons is held at a distance x. So if the electron is released now, determine the acceleration, magnitude, and the direction of the electrons. So as I said, based on the condition given, the mass of the positive charge is greater than the mass of electrons, and therefore it is more likely that the electrons is going to move to the location of positive charge. So first, so I will just draw so these are positive and this is negative, right? Positive charge electrons is considered as negative charge. So therefore, the force is going to be so the force is going to be towards the so this is attracted, right? This, as I said, is going to be attracted, right? Okay. So of course Q is also attracted to E, but again, as I said, the the motion is more likely that the electrons is moving towards Q because given this condition. Okay, so these two arrows represent the force experience. So let's say I will just, both should be the same. In magnitude it should be the same, but in direction wise is different. Same in magnitude, as I said, the direction is different. So I'm going to resolve these two vector here. I'm going to resolve these two vector here. Never mind. Maybe I just put it in the calculation so that you can see that the vertical component of the force F and F prime. That means if I resolve these two vectors, the vertical component of the force F and F prime will be cancelled off. But I will just show in the calculation. So assuming the axis here, so the axis here is, let's say, this position here, it is 0. This is at the origin. We can assume that, yeah? So this is, let's say, this is my y-axis, and here the x-axis, is already given to you. So assuming that these two charges is at origin, okay? So force F, okay? So I will just write K. So I won't calculate, I won't put the value. So I just put the constant K value. So Q times E, all right? So what is the R here? So what is the R vector? So what is the R vector here? So it should be the same, right? The R. So R is just R vector. So it's going to be negative x cap. So let's say this R prime, yeah. Plus d over 2 y cap. Okay, so the whole distance is d, so half of it is d over 2. And R vector prime, so x negative x cap minus d over 2 y cap. Okay, so it's below. So one is above, one is below. Yeah. Okay, so now, so the magnitude of R cubed times R. So it's KQ times E. So the magnitude of R here is square root of x squared plus square root of x squared plus d over 2, d squared over 4. Whole thing cube, yeah? Whole thing cube. And this is negative x cap plus d over 2 y cap. Okay. And similarly for f prime, so everything will be the same except the vector. The vector r prime. So the magnitude as well is going to be the same. So therefore the net force on the electrons, yeah, exerted on the electrons, therefore the net force experienced by the electrons. So force total force. So it's going to be F vector F plus F prime. Yeah. So here we can see again, if we add both of the vector, the y component is, I mean, here represent the vertical component. So the y component is going to be cancelled off. So if I add both together, so it's going to be 2 times all right. So determine the acceleration magnitude and the direction of electrons. So we have, since we know the force, so we can also associate now the force experienced by the electrons. It is therefore is equals to the mass of electrons times the acceleration. So therefore the acceleration, it is therefore the force experienced by the electrons divided by its own mass. So in the direction is in the towards the negative x direction. Yeah. So from the diagram, on the right, to the right hand side is positive direction, positive x direction, and to the left hand side is negative x direction. Okay, so we have determined part 1, Roman 1. Okay, we have determined Roman 1. So now the second part, determine the position where the acceleration is maximum. Okay, so this is part Roman 1. So in order to determine the acceleration is maximum, so we have to basically find where is the, because it says position, determine the position where the acceleration is maximum. So basically what we need to find is the position of x, right? The position of x with respect to the acceleration, right? So therefore, in this case, we have to differentiate the uh, the acceleration with respect to x, because we want to find the maximum, right? We want to find the maximum. Okay. So this is x squared plus b squared over 4 negative 3 over 2 plus sorry, minus negative 1. Okay, sorry, multiply with negative 1 because I differentiate x here. Then plus x. Okay, plus x times negative 3 over 2 x squared plus d squared over 4. Let me just rewrite this. I need to save some space. So this negative 3 over 2 is you differentiate the term of the denominator term. Yeah, we differentiate the denominator term. So it becomes negative 5 over 2, and we have to differentiate inside the square root. Yeah, inside the bracket basically. So which is 2x. So the whole thing divided by x squared plus d squared over 4 cubed. Okay. Okay, so now, therefore, for maximum acceleration, so this implies dA dx is equals to 0. So we need to find a position where the acceleration is maximum. Okay. So now, so in order to be 0, my denominator cannot be 0, right? So the 0 part means the numerator part will be 0. So this implies that x squared plus d squared over 4 so 2x squared, sorry, not 2x squared, it's negative 3x squared. So minus 3x squared equals to 0. So if I multiply the entire equation, both sides, if I multiply both sides with the power of that means, let me just put a bracket so that I will multiply, that means I will just multiply both sides with x squared plus d squared over 4 5 to the power 2. So if I do that, on the right hand side will remain 0 for sure, and on the right hand side will remain 0. On the left hand side will then be negative x squared plus d squared over 4. So it's power of 1. Yep. So minus 3x squared, right? Equals to 0. Just give me a second. All right. So just give me a second. It is minus, right? Because, sorry, it is minus, right? V, so is, sorry. So let me just write it down. So is, if this is U and V, then I have V du dx minus U dv dx divided by V squared, yeah? So it should be a minus. So it's a plus then. Okay. So now, so this 2x squared plus, sorry, minus d squared over 4 equals to 0. Okay. So therefore, um, so here I have x squared. So x is equals to then square root plus minus d squared over 2 times 4. So which is 1, so which is plus minus d over 2 square root 2. Yeah. Yeah. So that's the position basically. So that means at both ends, that means so if let's say we measure, if let's say we assume that this is 0, so at the distance where d divided by 2 square root 2, this point or this point. So this is d over 2 square root 2, and also this point here, d over 2 square root 2 is the maximum. So this is the maximum point. Yeah. So that is the position where acceleration is the maximum. Okay. Okay then. So now move on to part C. So in free space, a point charge Q1, 25 nanocoulomb is located at P1, while the other point charge Q2 is 60 nanocoulomb at P2. So calculate the electric field intensity at this point. So again, it's like a Coulomb's law problem. So what I need to do is I need to find the position vector from P1 to P and P2 to P. Because they said, because these are the charge located at P1 and P2. So we want to find what is the electric field contributed by Q1 and Q2 at point P. So let's say R1 is position vector P1 to P. and also R2 position 2 to P. Okay. Then magnitude of R1 so it's going to be square root of 41, and magnitude of R2 square root of 45. Okay, so therefore E1 so remember K is the one that we calculated earlier, so which is 9 times 10 to the power of 9. So K is, remember K is 1 over 4 pi epsilon naught, and we have calculated earlier, which is, the value is, we already know. So 25 times 10 to the power of negative 9, which is the charge of Q1 divided by square root of 41 cubed. Negative 3x 44. Okay. So negative 3x cap plus 4y cap minus 4z cap. Okay. And E2. Okay. So um so that is the E1 and E2 contribution. Therefore the net electric field at point P E net So we add both. So we should get okay. So that is the electric field contributed, both contributed by, at point P by Q1 and Q2. So determine the coordinate on on y-axis. Determine the coordinate on y-axis such that the x component of the electric field is 0. Okay. So let's say uh, let an arbitrary point on y-axis such as the coordinates is 0, y, 0, right? So it is on y-axis. So that means there's no x component, there's no z component, there's only y component. So again, I will say let R1 prime, so that will be our new position vector from P1 to this point. Okay, so both magnitude we already found. So now we need to know that. So what is the y position such that the E net, so the E net at at the E net at x, the x component, the E net of x component, so x component is equals to 0, the E net. So that means if we look at, maybe I should just write first E1 and E2. So in general, E1, So at -4, so vector y plus 2, 7. So therefore, E net at x equals to 0. So which implies, I only take into account the x component, yeah? So that means E1 x plus E2 x equals to 0. The x component. Times -4 cubed. And then add with okay, so the k can be simplified. So that means we divide everything by k on both sides of the equation. And here we will have so both is square root cube, right? Both is square root cube. So the whole thing should be cubed. So I will I will demonstrate you the ratio first. Even though supposedly is not an issue, even though I don't do this ratio here, just to illustrate that the calculation. So just to illustrate to you that the calculation, the simplification of the calculation process. Okay, just let me check it's correct here. Yep, correct. So square root. So basically this square root. So no need. Take out the square root first. So is equals to 304 times Q2 is 60 divided by 25, which is 2.4. So the whole thing is raised to the power of 203. Okay, which gives us 1.4797. Yep. So now, so basically now we just have to solve it like a quadratic equation. So basically now we just have to solve it like a quadratic equation. So expanding this is y squared minus 8y plus 16 plus 3, 13. So it's y squared plus 4y plus 4 plus 65. Okay, so y is therefore, you can use your calculator or you can use the formula given, the well-known formula y squared, b squared negative b plus minus b squared square root of b squared minus 4ac. So you can use that. So therefore I'm going to use that formula. So divided by whole thing divided by 2a. Yeah. So this is equals to negative 22.13, negative 6.886. All right. So it's already time. So I will continue the discussion later in the evening. So we have an additional class later from 2 to 4. So I will continue this discussion for the last part. Um, question 2, yeah. Okay. All right. Chen Wei. Okay, let me check again. All right. Regarding the minus x thing, Kai Boon, which part are you talking about? The later you let me know what 2x to the power of 2. Which question is that? Okay. So, Wei, I will come back to you on the negative x thing. The u is negative x. Okay. Just let me check again. Yeah. All right. Thank you, everyone. See you.